So we are going to discuss two practical circuits where these things are actually used. One, you have a good idea. Other, although 100% same, but you may not have a good idea about that. And what's that? So we can consider a circuit here in which a battery or a cell is actually connected. Just a second. Just okay. And the other part is I make it a bit smaller. So in between this thing, we connect two resistors. So we call this thing as potential divider. Do you know that potential divider? One, you can use the formula. Other, what you can do. One, you can use a formula to find the potential drop across the first one resistor and the potential drop across the other resistor. But there is a much easier and a shorter way. But like it's I don't like it, but in this topic I do prefer it sometime, because it helps you to understand the next thing which I'm going to teach. The potential divide in a ratio proportion method. Are you familiar with the ratio proportion method? So if we have a potential V, so if we have a potential source V, and say that this is 80 ohm and this is like 40 ohm. So you know that the potential, how much potential drop across it? It's 80 out of 120 and it's 40 out of 120, where 120 is the total resistance, is right? Times the V times the V. So this method is called ratio proportion method. Are you familiar with this thing, that we can use it here? If you have problem, you can ask me that, okay, what I did. Actually, I did the same thing which I have mentioned earlier. The voltage drop across the first resistor R1 and R2. That's V1 is equal to the R1 divided by 120 is the total resistance, that is R1 plus R2. So 80 out of the total drops here and 40 out of the total drops in the second case. Got it? Same goes for the bottom one. 40 out of the total, which is R1 out of the total, sorry, in this case R2. So V2 is R2 out of the total, which is R1 plus R2 into V. Got it? So this is a ratio proportion method. Is it clear? We can use a ratio proportion method. Everyone clear about it? Okay. So I just remove these calculations. Say that we can use any combination of resistance. We can use any values for resistance. Now this circuit is actually pretty similar to if we connect it with a circuit. Just start. I just draw the circuit. So normally the wires which we use in circuits, like the ideally they have zero resistance. Ideally they have zero resistance. Just a second. So we use this circuit, and what we are going to do, instead of the two resistors, I place a resistive wire. Resistive wire means it's not like, just give me a second. I just plug in my, so a laptop. What is there? I just draw the circuit. So instead of the two resistor, if I connect a wire, a resistive wire here, this red means it has a resistive wire. So there is a total resistance of that wire, and the total resistance of that wire depends on the total length of this. So these two things are pretty much same. They can be solved on the same technique. What you need to take care of, remember the formulas which we have written. I'm going to write both the formulas, and their potential divide here is exactly the same way. We have a potential drop across first part. We have a potential drop across the second part. We have the resistance of the first part. In this case, we will have the length of the first part divided by the total resistance, which is the sum of the two parts, R1 and plus R2. The total resistance is R1 plus R2. And in this case, the total length, because total length is the total resistance, how long the wire, that much is the resistance. So L1 divided by L1 plus L2 into the total voltage which we have supplied, V, into the total voltage V. What is this thing? Actually, this thing means if I connect a voltmeter in this circuit, I connect a voltmeter here across this resistance, and that voltmeter gives me a reading. I just so say that we connect a voltmeter here. So the reading on that voltmeter is dependent on this form. Right? I make it small intentionally because I want to put a voltmeter. So if I put a voltmeter here, the reading on that voltmeter depends on this form. formula. Everyone clear with that? We have discussed that already quite a few times, that potential divider circuit. So this reading depends on the formula which we have written. So the reading on this voltmeter is dependent on this form, right? The resistance of this component divided by the total resistance. Now we connect a voltmeter on the other side with this circuit as well. So we connect a voltmeter here with this circuit. But what we do, we keep the one end of the voltmeter fixed, like I have fixed it with that blue dot, but other end of the voltmeter is free. Other end of the voltmeter is free. What does it mean? That we can connect the other end on this red wire anywhere. Just fix it. So one end of the voltmeter is connected with the red wire at one point. The other end of the voltmeter can be connected at any other point. The other end of this voltmeter can be connected across any other point on the wire. So if you connect it at any other point on the wire, it means you are dividing that wire into two parts, just like the two resistance. So one part has a length L1, other part has a length L2, and the total length is L1 plus L2, which is the total length, right? So L1 is this, L2 is this, so L1 plus L2 is the total length of the circuit. Got it? So it's just like R1 plus R2 is the total resistance of that path. So this way it is the same thing, 100% same thing. Only we have replaced the resistance with the length. So the ratios of the length will give you the voltage. Voltage drop across the first part of the length is V1. Voltage drop across the second part of the length is V2, and it depends on the length of the second part. Our length of the first part plus length of the second part, which is the total length, our V. So what we do sometimes, like when we are practicing question, we don't write L1 plus L2, we write V1 is equal to L1 over L, where L is the total length. I just write it to emphasize LT, the total length into V, and V2 is L2 over total length, sorry, V2 is L2 over the total length into V. So these are the things which we need to apply. Okay. So I'm going to practice few questions because these questions are the one which are going to problem when anyone tries to solve these questions. These are the questions which are going to like a problem a little bit because they are like a practice question. Earlier I thought I will leave that topic, but now I just practice it. So just give me a second. We'll practice these questions where we have to use the length of the wire. Okay, so just wait. So what you need to do, you need to practice this question number 61. I just shared this. Be careful to answer this thing. You need to apply the concept which we just discussed now. You can, all of you can actually solve it on a page and can send me the WhatsApp. Okay, I want to see how you work it out. Whether you do it right or wrong, that's not the problem. I just want to see you how you do it. Take your time, think on this question, and then, so what's the easiest way? The one which I mentioned, ratio proportion, the other which I mentioned. Okay, and the one trick I just mentioned it. Other circuit consists of balance length means when this galvanometer or voltmeter, whether they have written it here or not, it shows us zero reading. Okay, so try to solve it and just do it on a page. Whatever you are trying to think or calculate, do it on a page and share that page with me so I can see your thinking. So you can take your time and continue with this question. So we will use this potential drop across the resistance, and this is the potential drop across the length, and they must be equal for the balancing. So that's the what we use, and we will get our answer as B. So the next question which we'll practice is this. So we go to this part, but first, what about the formulas which I have written here? Are these formula, Najaf, you said that you have a problem with the formula. Are these formula clear or not?
These are clear.
Exactly the 100% same formula I have used. I just make that thing copied and a smaller version of that. Just okay. So we paste it here. So they have said that this length 12.5 is balanced by the resistance PQ. So it means that whatever the potential drop across the 12.5, so the potential drop across the 12.5, if we use the length formula, this one. So what we get, the potential drop across the 12.5 length out of the whole length is just 12.5 out of the whole length of 100 centimeter. So 12.5 out of the total length 100 times the voltage. Voltage was L. So that is equal to, this one is the resistance formula. R1 and R2 was the total resistance. In this case, we have three resistors. In this case, we have three resistors. So 5 out of 30. Got it? Times the M. That's the potential drop across this one. Is that right? Any problem with this one? That's the potential drop across that PQ. Is that right? Say yes or no. No problem with that. We are here to discuss. Najaf and Bakhtawar, is that clear?
Yes.
Okay, that's great. So they have, in the statement, they have said that these two things are equal. So I put it equal here. So 5 over 30 into M. They have mentioned the statement that these are equal. They have not given me the value of L and M, so I work out the value of M over L myself. So when I work out the value of M over L, so 12.5 into 30 over 100 into 5 is equal to M over L. That give me the value of M ratio L. So what you get? Bakhtawar and Najaf, what we get if we solve this thing?
3 over 4.
3 over 4.
Over
That's right, 3 over 4. Yeah, 3 over, and when you solve it, you will get 3 over 4. Is that fine?
Yes. Yes.
Okay. Now remember this value, and we do it for every else part. The second part in the option, they have written that you need the potential difference across the QR. So the potential difference across the QR is 10 out of the total resistance of 30 times the total potential of M. Got it? And for it, I call the balance length for it will be X. So X out of 100, X out of 100 times the total potential across the 100 centimeter length is L. They must be equal. Just like these two are equal. So for the balance length of the QR, which we have called X, this must be equal. Is that right?
Yes.
So when we
Yes.
solve it for X, we have the value of M over L. So you can just check for X, it will be M over L into 10 into 100 over 30. Got it? You get X equal to 25. Is that right? And same, the next they have mentioned for Q to S. So for Q to S, the total resistance is length, I call it Y out of 100 into the voltage L, and that must be balanced by the resistance from Q to S was 25 out of 30 into the voltage M. So I need to find just Y. So Y will be equal to 25 into 100 over 30 into M over L. Got it?
How was it 25? When did we get 25?
Q to S. What's the resistance for this whole path? Q to S. They are not asking Q to R or R to S. This Q to S.
Okay.
Now,
So that's what we have. So it's a like that's why I said in the beginning, it's more like a ratio proportion method. Earlier I was about of a mind that okay, I leave this topic and I will move to the next topic, which is the waves. But then I thought, okay, we'll practice it. But actually, no need to worry. I'm again saying you cannot be like a master of this just by learning the topic. Just like discussing the topic we discussed it today. For this thing, you need to practice a lot of questions. And yes, there are a lot of questions you will find in the past papers on this little technique of that, like they use it wire. So like this is a wire, and you will see there are other questions. So there are many. There will be many other questions. Like I just skipped question 15 was the same. Is there any one of you like having class at like after 15 minutes? Like any other class, chemistry or some other class?
Me and Zainab have class, chemistry class at 5, an hour later.
Okay. Zainab is, by the way, not in the class. Somehow she get disconnected, and yeah, we do have class. Okay, so I will compensate that 30 minutes sometime later. Look at this. In this case, you have to use 100% same technique, but what's happening? They are not giving the values. You need to leave the answer in terms of the ratios. Got it? Try to do it, then I will discuss it with you. Okay, I will check. I doubt that answer, by the way, but let's see. First thing which we have to assume that actually whether it's the length of the wire or it's the two resistance, they are connected across the same points. So when they are connected across the same point means their potential difference of this, the total potential difference across the whole length of the wire and the total potential difference across the whole two resistor is the same. The total is the same. So this one is, let's see this. Okay, I just discuss it. Okay, Hassan says that can be a possible one. Let's see. Because I have not opened the marking scheme yet. So what happened? Across R1, the potential drop is V1, and that is equal to you can write it in two ways, R1 over R1 plus R2 into the total voltage V, right? But with the length, they said that it's a balanced length X. So the same potential V1 in terms of the length, the same potential in terms of the length can be written as V1 is equal to X over L into V. And similarly, when you work out V2 in terms of the resistances, it is R2 over R1 plus R2 into V, and in terms the remaining length is L minus X. So V2 is equal to L minus X over total length into V. Is that right? So you can see that they have given the answer of the ratio of V1 and V2 with the lengths, not with the resistance, right? So you will use these two formula and divide them. So when you divide them, V get cancelled, the length get cancelled, and you get V1 over V2 as X over L minus X. Yeah, Bakhtavar, is it clear? Najaf, your answer is right. Hassan, your answer is right. Bakhtavar, have you got the idea?
Yes.
Okay, so the technique is the same. You need to be, if you want to solve it much easy, like with ease, you need to be good at ratios. They can switch. There's only because students sometimes try to generalize things. Be careful not to generalize it, because in some cases, resistance is not proportional to length all the time. Like in every case, because some cases there's a question where they have a wire with a non-uniform radius, right? In this case, we cannot say that resistance is proportional to length. That if we have equally three parts, it's not possible that we have the same potential drop here, same potential drop here, same potential drop here. No, it's for the uniform thickness wire. Okay, but you need to use ratio proportion methods. Okay. Sorry, last time I have not sent you the question. I will try to send the question today, and we will check the Friday class, because I myself use here right now. I think all of you are in Pakistan except Najaf. Is that so?
Yes.
So if most of the people are using the Wi-Fi like wireless broadband, like the internet from the SIM or like any other wireless device, other than the modems, Wi-Fi modem in the home, then what happens is that their connectivity will be may get affected due to 9th and 10th of Muharram. So we will reschedule that class for next week. Okay, the Friday class will be in the next week. So till then, what I can do, I will send you the questions on topics. Do take a print if you have a print facility and solve it on a printed paper and send it back to me. I was like send it to, I have to send it to you last time, but I didn't. But I will send it by today. Okay. So we are done with like only waves. It will waves may take just next week to complete, because in next week actually we have 8 classes, 6 regular and the 2 makeup class for this Friday. Okay, so 8 classes I think are enough to complete the waves, and then we may need 2 classes to complete the particle physics or the atom and physics. So we'll be done with that. So any question from what we have practiced today? You need to practice these questions. You can practice as many questions apart from the, like I just practiced today with the question or with the length of the wire. You can also practice the questions with the variable resistor, like just this one. Got it? So any question from what we have practiced today?
No, sir.
Okay, so that's it for today. So thank you. Have a nice day. Allah Hafiz.
Allah